Okay, so in this question it's 30 divided by 1 5/6, which is 11 over 6. To divide by a fraction, you turn it upside down and multiply. So it's 6 times 180, or 30 times 6, which is 180, divided by 6, which is 16.4. Maybe we error there. So it's 16.4 miles per hour. Now we're going to do the same for Dermot. Now the speed is distance over time, and if we look back at the book, the distance that Dermot goes is 20 miles, and the time it takes him, this is much easier, is 2 hours. So it's 20 miles divided by 2 hours, so 10 miles per hour. Part C. What time do they pass each other at? They pass each other here at 13:30. Who is further from the destination when they pass? Now Claire has got another 10 kilometres to go, and Dermot has got another 10 kilometres to go. So they're both the same distance away from their destination. Now the next one I want to look at here is quite a wordy example. A man has 40 metres of wire fencing, which he wants to use to make a rectangular pen. He uses a wall for one side of the pen. So I'm just going to draw a wee picture out of what I'm seeing here. So that is your wall, and this is your pen. The width of the wall is x. That's x, that's x. Now he's got 40 metres. 40 metres. So the length of this has to be 40, take away the two x's. Write an expression for the area. So the area of that is length times width. So it's 40x, take away 2x squared. You just multiplied both of those by x. Draw a graph for this. Now, because you're talking about x as the length of something, there's absolutely no point in me putting in negatives. So just work with a few positive values. So x is 1. 40 take away 2 is 38. If x is 2, that becomes 80. Take away 2 squared is 4 times 2 is 8. 80 take away 8 is 72. If x is 3, 40 times 3 is 120. Take away 3 squared is 9 times 2 is 18. So it's 108. If x is 4, 40 times 4 is 160. Take away 4 squared 16 times 2 is 32. Gives you 128. Putting in 5. 40 times 5 is 200. Take away 5 squared is 25. Times 2 is 50. 150. I'll keep going until I start to see a pattern coming here. Putting in 6. 40 times 6 is 240. Minus 6 squared is 36. Take away, or times 2 is 72. So 240 take away 72 gives me an answer of 168. Still getting bigger. If x is 7, I'll just put these numbers into the calculator to save space. 40 times 7, take away 2 times 7 squared is 182. Putting in 8. 40 times 8, take away 2 times 8 squared is 64. Gives me 192. Put in 9. 40 times 9 minus 2 times 9 squared is 198. Putting in 10. So 400. Take away 2 times 10 squared is 200. I'm still going to continue on because it's a quadratic graph. I'm expecting it to come back down again. Put in 11. So 4 times 11 minus 2 times 11 squared gives me 198. Yep, the numbers are starting to come down again. Put in 12. 40 times 12 minus 2 times 12 squared gives me 192, and I can work from there. So very rough graph here I'm going to be drawing. I'll just go up in twos. 2, 4, 6, 8, 10, 12, 14, 16. And we're going up to 100 or 200. 50, 100, 150, 200. So 1 goes up to 38, 2 to 72. I'm just going to plot the even numbers. 4 up to 128, 6 up to 168, 8 up to 192, 10 up to 200, and then I'm starting to come down again. 12 up to 192, and you can see the symmetry taking place. So if you did a few more values, you would get that shape of curve. And it says, what are the dimensions of the pen such that the area is the greatest? The area is the greatest up here when x was 10. And you want the dimensions of the pen. So if I look at my pen, that means the length, or the breadth is 10, and the length is 40 minus 2 times 10, which is 20. So your answer is 10 metres and 20 metres. Now, another of these story questions which are difficult. A country will increase by 20% every 10 years. The population is 30 million in year 2000. Draw on a graph to show the next 60 years. So you're going to have the year and the population. So in 2000 it was 30 million. I'll just put in population in the millions and not write out all the zeros. In the year 2010 it's gone up by 20%. So take your 30 and times it. The quickest way of finding if something's going up by 20% is putting up to 120%, which is 1.2. So I'm going to go 30 times 1.2, which is 36 million. 10 years later, it goes up another 20%, so just times that by 1.2 to give me 43.2. It goes up another 20%, so times it by 1.2. I'm using compound percentages here to work this out. 2040, it goes up by another, times and by 1.2. 0.21. 2050, times it again by another 1.2. So it's 74.65, and I have to go up to 2060, so times it again by 1.2 to give me 89.58. Draw your graph. A very rough graph again. 2000 is my start. 2010, 2020, 2030, 2040, 2050, 2060. And up the side, we'll go starting off at 30 million. So 30, 40, 50, 60, 70, 80, 90, 100. That's the population in millions. I'm plotting on. 2000 was at 30. 2010 went up to 36. 2020 up to 43.2. 2030 up to 51.84. Next one's up to 62.21. 2050 is up to 74.65. 2060 is up to 89. Point that. And it's a curve. Looks like your exponential curve. And the question says, estimate when the population will first exceed 45 million. So you go up to where 45 million is, and you read across and down. Oops. So I would guess your answer would be about 20, 23 or 24. Now, the last of these questions here is another tricky one. A radioactive substance has a half-life of 5 years, so that means every 5 years it goes down by half. If there is 40 milligrams of the substance initially, how long will it take to decay to that? So we're going to start after no years. So this is the years, and this is the amount. So initially it's got 40. After 5 years it goes down by half. After another 5 years it goes down by half. After another 5 years it goes down by a half. And so on. So every 5 years you're dividing by 2. So 1.25. And you can plot that on. Although we can see from our wee table, we can answer the question immediately. It will take 25 years to reach down to 1.25. But I'll just plot this on because it's an interesting wee graph. 15, 20, 25. and that's the years, and this is the amount. And it started off at 40, and so let's get our wee axes labelled: 10, 20, 30, 40, 5 and up to 20, 10 to 10, 15 to 5, 20 down to here, and 25 down to where we want to go. So you can see it's a negative exponential graph because it's petering off as the graph goes on.